Martin. We'll need to adjust the, I can do this one, sorry. Let me put the right one, because we're already preparing for the next one, but we actually need my one first. Okay, so let's do this one. Okay. Okay, can you see it, Martin? Do you see the right one now?
Yep.
Okay. Sounds good. So thank you everyone again for coming to this session. So today I'm going to talk about a problem that maybe some of you have now, or some of you will experience soon as, let's say, you will start implementing the AI, software development lifecycle, that you will see will put a lot of stress on your systems, not just on the version control, but also on the CI/CD. Maybe, Jim, you've seen some of your clients, they are starting screaming and shouting because they have issues, right? Okay, so let's get started with the presentation. So, is anyone from BMW? That's a BMW, isn't it? That's a cool one. And actually, it's the one that is winning, which is a good start. Okay, let me just reboot the audio, otherwise there's going to be some echo. Okay, so today I'm going to talk about how can you make sure that your Git server and your SCM, and then maybe you will follow up with Jim, we will talk about Zool, maybe on the coffee break, because the CI/CD as well is important, can keep up with the challenge, right? Because everyone wants to go faster, right? So does your company want to go faster with the software development lifecycle? Yes, everyone wants to go faster, because otherwise why people should implement AI? They want to deliver features faster than the others. But we know that writing code is not actually the bottleneck. It's everything else that becomes the bottleneck. So once you start having stuff that pushes, you need to upgrade your car. For instance, I really like BMW cars, but can you do the Daytona race with the standard BMW? Maybe not, maybe not. So you need this type of BMW. That is a standard BMW car, but with some additions to it, right? So maybe you'll move this one there. So let's go. Oh, shall we switch it off? What do you think? Yeah. Switch it off, and then we'll switch it on back again. Okay. Okay, so first, how many of you don't know who I am and what is GerritForge? If you don't know, okay. So I'm the CEO of GerritForge. We are a company that is specialized on open source. And we have been contributing to the Git project for about 10 years or so, and to the Gerrit Code Review project for about 17 years. And actually, I was telling my son that actually I knew Martin Fick from NVIDIA well before he was born. And actually, Martin was the first person that I ever met from the community. I believe we were in the first Git together back at the time, and it was me, Martin, and Pef sitting on the same table. So we work on many technologies, right? So Gerrit is one of them, but not the only one. And most importantly, we work a lot on JGit and on performance. So you will see in the technologies also Gatling. And Gatling is the tool that we adopted and extended to support the race of making things faster. Because if you want to really to make things faster, you need to identify first your bottlenecks. And I'm really glad that Martin Fick from NVIDIA will present after me, because he will present also his challenges in making things better in NVIDIA, right? So about me, I presented myself. I really like numbers, so those are my numbers. 3,820 contributions over 97 projects in 17 years, which is good. This is just the Gerrit and GitLab part. And of course, I'm covering also many other hats. Together with Tony, we are release managers of Gerrit Code Review. We are both maintainers. And together with Martin, we are also committer of the JGit project. That actually the picture, Martin. So you were there next to me, number 3, right? That was in the middle. And number 2 was Pef. And we were introducing ourselves. He was telling me that he's working for a startup, and that was called GitHub. Nobody knew about it. What is GitHub? So I'm working with a startup with a guy called Scott. And anyway, we met, we kept in touch, and GitHub became such a big company after that. So this is our agenda for today, because making things faster is not really a one-off, but is a continuous race. Every time you have good moments, every time you have chicanes, right? And you have bad moments, and sometimes you go off-road, right? And you crash your car, but you learn and you improve. And that's the same thing about the speed. Improving the speed in Gerrit is like, let's say, a roller coaster. It's like a race. And you need to make sure to do all the chicanes right and also learn from all of them. And we are not alone. That's the point. It's a team effort, right? Not just us, but us with the rest of the community. So we started a long ago, actually Sean started a long ago by putting a very important point in the way that we write software in Gerrit. Sean was always saying performance is a feature. He was saying we can't really get a new release of Gerrit, things get slower. Because if a feature is slower, and a server that I had before, and I know you guys run large servers with large user base and large pipelines. If you roll out a new feature, and that new feature makes things 15, 20%, or 30%, or 50% slower, it's like the feature isn't working, right? And I'm really grateful for Sean because he gave us this point of view. And we use that point of view in all the development that we are doing in Gerrit. We are really so focused on making things right and making things fast. Then the race continued, of course, because Sean identified the navigation of the Git 3 as one of the main problems of some of the operation in Git. And then he worked together with Colby, and that was another hackathon that we did at the time when the meeting was called still Git Together, right? Git and Gerrit. And I'm really grateful that we got Git people and Gerrit people because we can exchange a lot of information together. And at that point, there was Git and Gerrit that actually Colby was working a lot on the Git side. I was together with Colby, and Colby, with the guidance from Sean, did the first implementation on the Git bitmaps. And the first one was done in JGit, and then, of course, all the SIGIT implementation followed. And there were then many years, kind of difficult years, because we lost also Sean, who died from lung cancer. But Sean was so good, he managed to get people that were like-minded, so they had the same kind of vision, and we continued his endeavor in his vision. And back in 2023, we started actually a research project. We wanted really to see if there was a completely different way of optimizing Git performance. So instead of trying to tune it, let's say manually, we'll say, why don't we do some experiment? Why don't we use something that we believe is useful from some AI techniques, and specifically reinforcement learning, by instead of forcing Git to do certain things, we say, why don't we let Git learning about what to do, right? Learning from what? We'll see what we did. And then we spent about 3 years in research. We actually published a paper, and then that was shortlisted by the International Conference on Computer Science, and has been also presented in 2025 by Shane McIntosh, that is one of the speakers and professor of the University of Waterloo in Canada, that is coming, actually came many times also to present at the Gerrit User Summit. And then lastly, that's very important, so we put then the tool that we developed that is called GHS on the lab, not just with Gerrit, but also with GitLab. And I shared already a couple of months ago with Patrick the results. And actually, we're doing the same now with GitHub Enterprise. But we could do the same also with Bitbucket or any other Git server. So let's get started. This is what we are going to see in today's race. So just as a disclaimer, so that's very important. So all the research we have done has led to the identification of a lot of bottlenecks in a lot of pieces of open source. We contributed all of them. So it means any time that we saw some bottlenecks or some problems, we fix them. And all the fixes and contributions have been 100% open source. However, the research work is covered by patents. So the research work has been patented, and it's patented in the US and the EU. The reason is very simple, because it's not the first time that we invent something new, and then the problem is the community needs to have also some kind of consistent funding. And at the moment, the Gerrit community doesn't receive, let's say, millions of dollars by, let's say, some kind of charities or donation all across the globe. So we say, we build something open source, and we make sure that we can continue doing it, right, in the future. And patent is one of them. Having said that, the code is open, right? The code is open, the patent is open, and also if you're interested in understanding exactly how is it done, absolutely, we can go and show you, right? So I'd like to start with actually yesterday's talk from Qualcomm that I really liked it, right, from Vazdev. How many of you followed the talk yesterday from Qualcomm? Okay. For the ones that didn't follow, basically Qualcomm showed their AI pipeline. So they already integrated Gerrit code review and their CI/CD pipeline with AI. And they have a sophisticated system that basically listens to events through webhooks and then have this engine that tries to understand what Apache is doing. And then they've got, of course, all the code generator that will try to fix stuff, right? And that is all integrated. So if you want to replay yesterday's presentation, it's still on YouTube. If you go on the yesterday presentation, you will see it. I will leave it there, publicly open for everyone to watch until, of course, we cut it and we do the post-production that will be, let's say, published in a more, let's say, organized way. But if you still want to, I don't know, over lunchtime, you're curious, want to see how Qualcomm did, it's there. And one thing that was really interesting for me is that they saw challenges. Challenges not just with Gerrit itself. Some of them are very well known. So H2, we know H2, the version they've got has problems. It's single-threaded. My new versions have got multi-threaded. But they had very big problems with the scalability, right? The new AI use case created a massive workload that they didn't have before. And the only way they see to resolve the problem is scaling up the Kubernetes cluster. Today, I'm not going to talk about Kubernetes. I'm going to talk about a different way to improve your performance without spending more money on Kubernetes. So from that point of view, sorry, cloud providers, we are not going to earn money from this talk. But you guys, are you guys cloud provider? No? Okay, so you spend money on cloud. Do you want to do more with the same money? Yes. Do you want to do less, spending more money? No, right? So let's see how can this be useful. So let's start with Sean, as I mentioned before. So for the people that thinks that Sean was only the project founder of Gerrit, actually Sean was spending an awful amount of time on Git. He's one of the top contributors of Git. And Sean's office was exactly the next desk of a Juno office, right? And that's why they were doing it together, because it was also very handy for them, because they said, we do a conference, so we can book the same conference room. We have to ask the manager just once, and that's it. And Sean did a lot of work. If you're just curious about what Sean did, Sean introduced the concept of caching in Git. I'd be sorry that he did just for JGit, but he could have done also the same for Git. He invented a smart HTTP protocol. So before Sean, Git was using HTTP with WebDAV protocol that was so awful and so unoptimized. And he invented that protocol. He did so much more on the Git project. Then another person that is really important is Colby. How many of you met Colby Ranger face-to-face? Just the two of us. That's why we go white hair, right? The only one. But Colby is great, absolutely. I remember speaking with him, he was just genius. And the only thing that I would say from Colby, I would have loved, let's say, maybe more technical documentation about bitmap, because speaking with other Git maintainers, so I believe Patrick, we were speaking over dinner, he was saying, I don't believe Git bitmap is working because sometimes it makes things slower. And I agree. Sometimes bitmap makes things slower. But if you know how bitmap works, it can be so much faster. And then this is the team of people that worked on the research project. So the research project is not just me, but me plus many other people, was directed in terms of the theory and all the kind of science behind it by Shane, that is associate professor at the University of Waterloo. I was managing overall and giving guidance, and you have here, one on the team, actually there was yesterday as well, that did all the research work, right? And this is exactly what we use. That's why we use Gatling. Gatling Git has been really key. So Gatling, how many of you have heard about Gatling before? So it's really powerful. It's able to go and mimic the shape of traffic very, very carefully, right? And this is what we did. So because we provide also GitHub.io, that is a free service that anyone can use for using Gerrit code review on top of their GitHub repos. And you won't believe it, you know how many people are using Gerrit workflow on top of GitHub? Guess the number? Who wants to try? You want to try? How many? So? 7,000. Someone offer more than 7,000? 7,001, 7,002, 7,003? Tony?
I have no idea.
Tony has no idea. 50,000 people every single day, they prefer using Gerrit on top of GitHub. It means they like GitHub. It's a fantastic user experience. The code browsing is so nice. The code search is so nice. Code review, I would rather prefer Gerrit. And they use GitHub. So we use the data anonymized to understand the shape of traffic on GitHub. And thanks to Gatling, we kind of configure Gatling to replay exactly the same logic. What's the value is that then we could amplify that specific traffic and squeeze that traffic in a very short time. So we managed to squeeze 1 year of traffic in 1 hour, okay? And then we put a repo on the stress. We didn't want to start with a super large monorepo, so we start with a repo that is not very big, actually. So 100,000 refs is not very big, right? 1 million objects is not very big. I believe maybe Marty will talk about your, will you show numbers? A little bit. So you see his number is much bigger. So it means this is not a problem to solve just for very large companies. This is regular repos. And you will see, you will be amazed by the data, right? This is, if you want to know a little bit of details, this was not a small machine, right? 128 gigabytes, decent, 128 CPUs, local SSD, so there was no issue with the file system, no NFS at all. So you couldn't say that there is, oh, that's the network. And there was wide connectivity between the client and the server. And the client was powered enough not to be the bottleneck, right? And we use those versions of Gerrit. Gerrit Code Review 3.12.2, if you have been really careful of what I was saying yesterday, it's because I used that version, because RefTable didn't work before. So we wanted to use all the latest and greatest. So we used Gerrit with RefTable, and that's how Tony found out all the problems with RefTable, because with this massive load, all the problems comes out, right? We use GitLab CE 17.8.1, which is not the last one. Maybe we should repeat it with the last one. Last one is 18, right?
18.4 is the
Yeah, 18.4. We use GitHub Enterprise 3.17.2. So maybe you take a snapshot of this one to see if it corresponds to the version that you guys are running as well. Do you run also GitLab or GitHub? Raise your hands. Okay, so that could be useful for you. And one thing, so how then we try to optimize the type of workload and the reaction time on Git, basically using the different dimensions that a Git server can have in terms of big. Many people, they misunderstand that big means large files. No, big means all the dimensions of Git. So the number of objects, that is really important, number of objects, because the number of objects are impacted by many of the phases that Git goes through. The counting, write walk, search for reuse, and search for reuse we identified as the main bottleneck. And we did a lot of optimization. Also, Martin did a big one on that one. Delta chain resolutions, bitmaps, yeah? This is what, let's say, we used. Is it all good, Martin?
The audio isn't working?
Audio isn't working? Okay.
No, it's just overlaying.
Delay?
The audio plays once and then like half a second later it plays again.
Okay. Okay, we'll try a different one. I don't believe I could do much from here there. Okay, let's continue. It's recorded from here anyway, so we will we'll sort it out later, okay? Then let's continue. Number of refs, this is big. We talked about yesterday, right? That's why we use RefTable, because we saw massive problems of performance and concurrency. If you run, let's say, a massive number of users going and hitting the same repo, with the packet rest just wasn't scaling, right? The packet rest was constantly created, updated, and then it was basically everyone was waiting, they were waiting on the same packet rest regeneration. So that's why we use RefTable. And then last but not least, the number of pack files. That is a big impact. So we gave as kind of tools to these reinforcement learning agent how to manage all the different optimization they can do on pack files, from repackage, geometry repackage, bitmap generation, and all that stuff. So one of the things that we have identified as a possible bottleneck is the lack of optimization of the bitmaps. Let me explain what it is. So if you've been running Gerrit or a Git server for a certain amount of months of years, you know that if a bitmap is not very well optimized, actually could be even detrimental for the point of view of the performance. So a repo with the wrong bitmap could actually go slower than a repo without bitmap at all. I believe some of the people have experienced that some of the repos, you reboot the bitmap, actually it's faster, right? Why? Because bitmap is a very, very big object. So it contains the reachability of all the objects against all the other objects. Because that amount of information will just be exploding, so it's a table that is sparse, right? So it means doesn't contain all the entries. And also there are certain settings that allow to define how much density you want in the bitmap now or maybe later. And remember, bitmap is just not one. So even if it is one file, that file contains all the bitmaps for all the different heads and tags that you've got in the repo. So first, JGit excluded the tags because people are kind of abusing the tags. Specifically when they do CI/CD, they use the tags for saying, oh, this is the stuff that I built, right? And then people tend to have something like 10 million tags or even more. And that inflates the bitmap a lot, right? And then we have increased and improved the JGit bitmap generation because we saw that there were many other bottlenecks. This is just an incomplete view of the settings that we have introduced in JGit. And they don't exist yet in SIGIT. As I mentioned yesterday, I quite like the SIGIT code base. So as soon as I get a little bit of free time, I want also to contribute those changes to SIGIT. To give you just some of them, so the first is the excessive branch count. So JGit has the ability to say if there are too many branches, then just don't give up, don't continue there, right? Another one is more tailored prefixes. So many companies, they define, and also GitHub and GitLab, they define certain prefixes or things that can potentially explode, right? And if you could say, listen, I don't care about those prefixes because at the end of the day, they will represent 99% of the size of my bitmap, but they don't represent 99% of the use cases that I've got. So why don't just exclude them? If someone wants to fetch those ones, I would just get 1% of the cost lowers, but the other 99% will be super fast. Then another two that is really important, so recent commits count and span. So this is coming from a different perspective. What is the likelihood that a CI/CD system will build changes made 6 months ago, or 6 years ago, or 10 years ago? Almost zero, right? So this one is telling exactly how much you want density for your bitmap. So if you say, if you got stuff that is too old, just give up. I don't care about those. By tuning those parameters, I was mentioning 2 months ago that someone managed to go from 2 hours of generation of a bitmap to 2 seconds, right? And I cannot say who was it, but he's in this room, right? So, and that's impressive. If you think about, would you like to save 2 hours of computing time of your server? I want. Because the server, if it doesn't stay there and compute the bitmap, can do something else, which is great, right? Of course, we want, let's say, to fund the cloud providers, but we don't want to waste money. Nobody wants to waste money. And that was absolutely time of the CPU and your money wasted. So the work that we did is available. So that's the research paper. If you want to go and to look at all the details, it's full of data, full of graphs, with all the details of the work we've done, and is available for everyone. And this has been peer-reviewed by the major universities in the world. And it's been then shortlisted for this summit. That is the procedure, that's the summit, ICSC 2025. This has happened in Canada. We are applying for the next one next year. And you can get all the details there. So I forgot to mention before at the beginning, there is a Q&A QR code. If you want to ask questions, you can scan the Q&A and you can ask questions online. Okay, so this is exactly how it works. So first, it's not going to change your SCM. So doesn't talk to Gerrit, doesn't talk to GitLab, doesn't talk to GitHub. And how it manages to improve your SCM. Imagine that your SCM is the BMW car that we were talking about, right? And we went to transform the BMW car to another BMW car that you see on the right that can win the Daytona, right? And I really like that race because it's really not super duper cars. It's like a regular car in that you empower it and you compete against the other. And then is to understand first how to keep a bitmap in good state. And the reason is, I don't know how to do it. Depends on the repo, right? But do you want the SCM manager to go there and try to understand the 100,000 repos you've got and how they behave? No, it's not a human thing. You should need, I don't know, you will need a kind of platoon of thousands of SREs doing that. But can AI do that? Yes. I believe this is what AI is made for, right? So allowing people with brain to keep the brain doing useful stuff and avoiding doing useless stuff, that is just looking at logs and crunching. The second thing, understanding how to minimize the invalidation of pack files. So this is very relevant for JGit. It's not so relevant for GitLab. But JGit is really important in keeping the pack files cached in memory and making that cacheability as long as possible. Because the moment that you go to the file system, you're losing time, right? Then on the other side, of course, also optimize the ref organization. That is, I would say, if you have already adopted ref table, that is a little bit less of a problem. Even if yesterday I talked about a little bit also of the challenges with ref table. And what is inside, this is very, very simple AI. It's not very complex AI, but it's using an algorithm of reinforcement learning. How many of you knows what is reinforcement learning? Otherwise you'll spend, okay. For the people that doesn't know, it's very simple. It is like teaching someone a new concept by just doing two methods. The first one is a little cookie. They say, you've done something good, then I give you a little cookie, so that's good. And the second one is the stick. No, you didn't do well, stick, right? It's the same way that you use for teaching maybe an entity that is not, let's say, computer science, right? So you don't use maybe a stick for your dog, but you say, don't do that, bad dog, whatever, right? It's the same technique that you would use for training any kind of human being or living animals for doing something. And the problem is, for being able to do that and achieve something that works, you need a lot of data. It needs a lot of learning. That's why we did this acceleration. So we did that one with simulation in the lab, and these are the results. So this is a graph that is really interesting because it shows Gerrit code review, the latest and greatest with ref table. So you will say, oh, but try ref table. No, this is with ref table. 3.12.2, and this is after 12 hours of heavy load simulating 12 years of traffic. Here we are plotting what is the cumulative time of CPU, right? So it means how much does it take to do certain operations, because certain operations are faster, others are slower, but overall you need to add them up. As you can see, the moment you continue the simulation, the trend is a hyperbolic, right? It means that the more you continue, the slower it will get. And there is no, let's say, silver bullet there. There is no simple solution. When you get to a point where really the system loads start getting crazy, you have to call everyone and say, guys, we need to do an emergency shutdown. We need to do some kind of emergency reorganization of the repo because there is no way we can continue with that. And if you run in production system, you may have seen this one many times. And this is when you got exactly the same setup of Gerrit, no changes, but you put GHS on the side. GHS is a small container, right? You just mount the file system, doesn't do anything else, but is doing a monitoring of all the metrics of the repo, and that's why I use the car, because this is exactly when you do a Grand Prix with a car, right? You need a lot of data. How many of you have seen the F1 movie from Apple? Have you seen it? So I definitely recommend, because looking at the movie, I say, that's GHS. That's GHS, right? Because the things they do, they get all these telemetry, all these metrics from the car, and then from the metrics, they display in a big screen. They've got some algorithm that says what to optimize on the car in real time. That's great. That's great, right? And that is the same exactly installation with GHS on the bottom, right?
In the example you've got there, do you have an estimate for how many times the agent tweaked the parameter? Like, is it happening many times, or is it?
Every 30 seconds.
Every 30 seconds.
And that's the key. So how can you do maintenance of a repo every 30 seconds. You can't, right? Because otherwise you spend most of the time. But this is not a maintenance thing, right? What he's doing is very, very small tune parameters. So he's trying to use very small adjustments on the repo. But the point is, he's trying to understand which one is the small adjustment that will give the maximum results. Instead of observing the metrics also, he's using a system that is going to estimate what will be the performance after that one. And the AI system is able to find what is the best choice for getting the best results. It's something that someone could do manually, you could do manually, but it's not human. Can you really do every 30 seconds, looking at all the metrics, understand what decision has to be made? No, you can't. But nowadays, with AI, you can, right? And he was learning how to do that. And the results are amazing with Gerrit. When we saw this one with Gerrit, 10 times faster, people say, wow. They say, man, but there's people running GitLab as well. Maybe GitLab is a completely different way of using the repo. They don't use NodeDB. Maybe they don't have this problem. And this was with GitLab. Not 10 times, 100 times faster with GitLab. That's version of GitLab. And we didn't change anything in GitLab. If you want to know more about the details, Tony did all the GitLab testing. I believe he was unsure of the results. When he saw the results, he said, wow, I wasn't expecting that. This graph is slightly different, but it's more detailed than the previous one because it doesn't tell you just the median of the response time. It tells you also the distribution, which is important, right? It's not just important to go fast, but important to have stable response time, right? So for instance, yesterday we saw the amazing presentation from Vasdev, and one of the good results, he was saying now it's a lot more stable when after I tuned the JVM with ZGC, now the performance are stable. And you see how much stability there is in the green one. The green one, this is the friendly name we gave to the AI agent. We like to give friendly names. So now is our kind of pet. Franco, we call him, right? And as you can understand from my accent, I'm Italian. So it's not Frank, it's Franco, right? And the other ones are the curves of GitLab. If you disable GC, of course, we know that it's going to go mad very quickly. But as you can see, the red one is the algorithm that GitLab uses, the one developed by Patrick in Italy, right? And it does quite a good job, but at a certain point, it doesn't keep up. It's not able to do it, right?
One question about the outliers there.
Hold on, let me switch on this one. There we go.
One question about the outliers there. Is this maybe an artifact of the way that you do the like condensed benchmarking, basically, because you squeeze it down into like 10 hours or something like that? And so I wonder whether the outliers are maybe cases where we just haven't been able to keep up with the actual traffic. And so under normal circumstances, these outliers wouldn't exist.
Could be, absolutely. It could actually be the case in a way that if you do the regular maintenance on the repo, maybe you do scheduled, right? You're not adaptive, you're scheduled. But my feedback is, actually, this is what happens in production as well, right? Or not? Is it scheduled or is metric-based?
It's both.
Both, okay.
We have both, but the thing is like, at times we, for example, have to decide to do a full repack. And these full repacks, they can take a lot of time.
Yep.
So that could be one of the issues here.
Yep. And that's the point. So, sorry, let me disable this one. And that's the problem. So if your maintenance takes a lot of time, maybe it's a time of the day where people are releasing and you just can't keep up. Or you don't have enough system load free to do some kind of recovery. And maybe that's why it doesn't really keep up. But the good thing is that if you run then GHS side by side, you got both working at the same time. So you got from one side the regular Git maintenance developed by Patrick that works well, and GHS makes sure that you never have this overload of system, so you still have time to do what you have to do, right? So you keep the repo in shape and you avoid the overload. So that's the good news, I will say. And this is real. So we are running GHS on GitHub.io. We have been running for many months. The repos are in good shape. So GHS expose a lot of metrics. I like data, I like metrics. Expose a lot of metrics that tells you first what were the actions. As you can see, the actions are taken continuously. GHS always do something. Even the action of doing nothing is an action, right? You decide there is nothing to do, right? But we still ask GHS, what do you have to do? The footprint on the system is not zero because, of course, you got one other thing that needs to run off the system, right? But it's limited to 1 to 2%. The saving in terms of system load is about 90%. So would you spend 2% of your CPU for saving 90% of it? I would, right? Because the overall, it means I save 88%. So what's next? So I cannot tell you the name, but we are now doing, after you've done all these AI things in lab and whatever, we did it in GitHub.io for many months. Now we are doing, let's say, with some customers on GitHub Enterprise in their system, because they were explaining to us that they rolled out their AI pipelines to GitHub. You know what happens? Fire. They're on fire. They say, we don't know what to do because you just can't keep up. And it looks like, I'm not an expert on GitHub Enterprise, but they had some limits on the scalability they can get to. Because GitHub Enterprise is not open source. It's not like we're discussing before dinner with Martin. It's not something you can go and tweak whatever. So it's there, and that's it. And there are limits. And we are expecting, and maybe in the next talk, next year we will talk about, I will show you all the graphs of GitHub Enterprise. We're expecting at least 50% reduction on the operating cost, which is big. Companies, they spend millions and millions every year for running GitLab on the cloud. Not licenses, running, clouding cost. Would they want to save 50% of that money? I believe they would, right? Okay, and this is what we are planning to do. We're planning to publish the results of this research to the equivalent conference next year. And I believe Shane will be happy because this time he's not in Canada, but he's in Rio de Janeiro. I believe we will like this place a lot more than the other one. But we'll see. And one of the feedback from the peer review was, can you show us some data now on the wild? So some real customer that used it, and can you tell me the metrics? And can you measure exactly what was the advantage, the traffic they were using, and so on? Okay, and now we go to questions. Any further questions? Let's go.
Do you know what provided the most savings? Like, is it the bitmaps, or just like how you do the repacking of the packs, or?
So the answer is, it depends. It depends. I've seen that in some of the cases is the bitmap optimization. In other cases is the refs. In other cases is the packing, right? So it really depends. It depends on the engine you're using, if it is Gerrit or if it is GitLab, because for instance, Gerrit is a completely different way. So for Gerrit, to give you some examples, loose objects are not a problem, right? And loose refs are not a problem because it's repacking continuously, right? But maybe there are some other issues, right, with the number of pack files. And the number of pack files are not a problem for GitLab. So, and also the way they use the repo is different. So if you have a repo on Gerrit, to give you some examples of AI agent that is throwing a lot of automatic robot comments into the repo, that will just make the repo explode, right? But the same will not happen with GitLab. So the answer is, it depends. In some cases it's one, in other cases it's another. It also depends on what is the shape of traffic it receives at that time. That's why we like the agent to understand what to do.
Makes sense.
More questions? No? Okay, thank you very much. And Martin, that's your turn. Okay.